So I said I'm Sal of GoFundMe, formerly of RelateIQ and LinkedIn. Let's learn some stuff about receivers. So I know what you guys are thinking. Each of you just came into managing a small football team, but you don't have a lot of money. So you've come to me and you said, Sal, you're a data guy. Can you help me pick the best wide receiver for my team? Right? No? OK. All right, we're going to talk about Spark streaming receivers. So first, a little tiny bit, because the nomenclature can be a little weird. Receivers are actually the sources of data in Spark. So they receive external data, but they're kind of akin to the source of the river Nile. Basically, that's where the data starts flowing, and then it flows down the rest of your stream where all your cool processing happens. Nicely, though, it's a little better than the river Nile. It's not going to take you 100 years to find it. You don't need the resources of a small kingdom. It's much, much easier and much more exciting, and you can do a lot of cool things with it. So I want to actually mention a quick quote, because it specifically applies to the type of receivers I'll show you how to build today. And this one's from Peter Norwig. We don't have better algorithms, we just have more data. It's theoretically attributed to him. I think he might have denied this quote. But this quote appears in lots of general data science presentations where it says, like, more features is better than more data, and more features is better than better models, and more data is better than more features. And there's kind of two ways you can grow this. One is if you kind of go from 1 to 2 million data points, you can build a much better model. But another, and in a lot of cases more powerful way, is if you increase the breadth of your data. And that could actually give you some new features that you wouldn't have had before. So I'm going to go through 3 relatively simple examples of receivers. The first one is a very simple financial web API. It gives you foreign exchange data, basically euros to dollars, pounds to dollars. Then I'll do a quick demo with Twitter, how to build your own stream from Twitter, and just an honorable mention for a queue system, which is kind of a classic place where we build reliable receivers. And I'll talk about what different types of receivers are as well. So I'm going to do a small little local demo at the end, which will be based on the Twitter receiver. It's the one we're actually going to build, and I'm going to run it, and it'll be a nice little word cloud with some live aspects. So maybe closer to when I do the demo, if any of you guys tweet to Data by the Bay, make sure someone tweets, they'll look a little cooler. But OK, so I'm going to go and talk slightly about the internals of Spark streaming, because that really helps understand how you build these data sources. So Spark kind of has 2 paradigms under its roof. The first, as you guys are probably familiar with, is batch Spark. And batch Spark is very akin to MapReduce, Hadoop, pretty much everything that kind of does a big batch of reads in data, does processing, and reads out. So it kind of looks like this. You start with some data, usually in a distributed format. And then you have 2 types of transforms. Some of them are just one-to-one transforms, and some are kind of reduces, repartitions. These will be your group bys, a lot of the joins. And then you kind of write the data out. So Spark streaming is actually very excitingly built on the same exact framework. And under the hood, Spark streaming is actually batch Spark. And some streaming engines, you kind of get a piece of data in, you do some processing, and you send the piece of data on. Spark streaming, on the other hand, is what's known as micro-batching. So every time you work with data, you actually work with a small batch of data. And they've actually done some nice code reviews where the base unit of processing in Spark streaming is a D stream, which corresponds to kind of one thing that happens. And a D stream is under the hood. Actually, it looks a lot like a generator of RDDs. And RDDs are the base units of operation in Spark. It's one of the possible units of base operation in Spark. So one of the really cool things about Spark streaming is under the hood, you can actually just kind of run a loop and do things that you would normally do in Spark. And you can actually even reuse the same exact code, which is kind of fun. So we're going to talk about the very first piece here, which is an input D stream, which is kind of the source of the data. And I'm not going to really talk much about InputDStreams because one of the nicest interfaces of these InputDStreams is just to wrap a receiver. So a receiver is a simpler interface, and for all practical purposes, just remember that there's a receiver InputDStream that kind of wraps a receiver, and then you don't really have to think about it too much. OK, so why did I choose this little simple foreign exchange API? Well, it's free, great for a demo. It seemed to have didn't have stupid rate limits. The Twitter was kind of definitely a pain point on that. For some types of Twitter data, you can only pull 15 times per 15 minutes, which was very brutal. The other one is this is historical data, and that is actually really cool. I'll talk about that a little later. And very simple HTTP call, so very nice for a presentation. OK, so I'm going to throw a little bit of code. In most cases, feel free to ignore it. There's actually a GitHub repo where I attached all the code if you care to look at it later. So this is a really simple example. It's not the way you usually want to call a URL because you kind of want to check for the server being down, all that kind of stuff. But anyhow, very simple connector, just does a simple get call and returns a case class. And that's all you have to do. So this is just your connector, nothing to do with Spark streaming. OK, but this is how we actually build a receiver. So this is the simplest possible receiver you can build. Nothing too fancy. If you notice, we have our connector. We're doing a simple get. And what I kind of want to talk about is what you have to do to make this receiver happen. So Spark provides you this receiver interface. It's actually abstract class, which kind of provides you some functionality for starting, stopping, but most importantly for storing data. So I'm not going to go through line by line. The demo is actually pretty good online. But I do want to talk specifically about the storing function. So the receiver interface provides you, or abstract class provides you several types of storing function. Some of them are blocking, and some of them are non-blocking. So this is particularly the non-blocking function, where literally all you do is every time you get a piece of data, you just hit store, and it kind of saves it into the Spark backend. And what happens is it kind of builds up data. And then whenever you have your little micro batch pulse, it will take all this data, and then it will save it to Spark. So kind of the disadvantages here, as you might see, is if the receiver goes down during the operation, you will lose anything between what is stored and between when Spark somewhere under the hood figures out that it needs to save this data. So this might not be a problem. This might be a problem. It depends entirely on what you're building. But this is by far the simplest possible thing. The other thing I wanted to call out is just the little boring thread sleep. Web APIs have rate limits. So you're going to have to do something along these lines. So this leads to one of the major disadvantages of kind of these little simple web APIs is you're really often limited to a single kind of node. Because rate limits and because you can't really do sharding very well with these simple APIs. So the question is, why would you even bother building the simple web API? Well, one, it's just a demo. But there's actually some legitimate use cases. So the first one is when you want to actually join with another large data source. So I think one of kind of the takeaways I'm hoping to bring is that it's really easy to ingest additional data sources, so you should. So let's say you have another large data source. Even if you just have a very simple small stream, it's very easy to kind of connect it to another large data source. And I have like a dummy example of that in my Git repo. So for this foreign exchange API in particular, this one is actually pretty compelling. So at GoFundMe, we process a lot of donation data. And this donation data comes across in US dollars, but also in pounds, euros, all sorts of exciting stuff like that. And just by joining on the simple stream, we can get kind of a real-time analytics understanding of what's going on. Another one would be heavy processing down the road, maybe if you cross your data like a crazy person. There's some neat Spark streaming specific functionality, windowing. Won't talk about much. This is an example of it a little down the road. Backfill data is kind of cool. So one nice thing about this TrueFX API is they also provide you with all the old foreign exchange rates in batch form. So this is specifically interesting kind of for the financial application where you kind of want to do backtesting. So you build your crazy money-making algorithm, and you kind of want to look at everything that's happened in the past. And what happens is if you actually build your stream to process this data live, Spark streaming actually provides you this nice little interface of a file input stream where you can actually plug in and read stream directly from a file. And the format of the backtesting data here is actually the same as the live API. So you can actually very easily just plug in a different input DStream, and suddenly you can do backtesting with the same exact code. The last one, okay, you can reuse code for batch processing, but the last one is kind of prototyping where, like I said earlier, you can really only have one receiver with a very simple web API, but a lot of times the web API is kind of, you just see something and you see if it works, and then if you're a company with money, you go back to these guys and say, build me a real API. And there you can ask for sharding, you can be like, grab this shard, this shard, this shard, and then you can actually have kind of some element of distribution. And you can also get rid of those pesky rate limits. Okay, so here's, again, a little, just treat it as code vomit. If you want, you can find the code later, but I kind of want to point out the one line. This is all you have to do to actually create your receiver stream once you built your receiver. And yeah, then I use the window, just some demo processing. And I know I told you guys that the GitHub repo has all of the cool code, if you want to look at it. I omitted this one function because I wanted to keep it for myself. But if you if you really want to know, talk later. OK, I mentioned this already, the limitations with a simple API. So mostly no sharding, rate limits, and the other one is kind of no acknowledgement. So if you build a very simplest kind of streaming processor, you're kind of starting over. If you take your streaming processor down, you're kind of starting over just where you left off. Or sorry, you're not starting over where you left off. You'll start off somewhere randomly, depending on how the API looks. So right now we're going to go kind of to Twitter, and we're going to kind of fix this last little piece. All right, this is where I take my quick drink. I know football references are not for this crowd, right? Wrong. Yeah. But it works really well, though. It's like, man. OK, so my second example is with Twitter. And here we're going to actually build what's known as a reliable receiver. So before we do that, I think we need to talk about what a reliable receiver is. So the previous example we just did, that is an unreliable receiver, which means, like I said earlier, if the receiver goes down, you lose data. Very exciting. So oftentimes you don't care, but every so often you do. So usually it's with something like a queue, where if you actually have to acknowledge that you got the data. But there's a lot of other examples where it might be also interesting. So the way that an unreliable receiver works, every time you get a piece of data, you just call this non-blocking store function and let Spark Herring handle everything else underneath for you. A reliable receiver, on the other hand, you actually drop down and take manual control. So what you do is you grab a window of data, and you kind of manually build up this window of data. And then you call a different blocking function. And the reason you partially want to build up this window of data is the blocking function can be kind of slow. So you only call it less frequently. And once you kind of do the blocking, then you do some kind of acknowledgement or understanding that you've properly processed your data. So usually for queues where it's the acknowledging mechanism is correct or kind of standard, so you have AMQP, SQS, all these kinds of queues. But we're going to do one without a queue. So this is what is a client-state reliable receiver. And I made that term up, so don't Google it too much. And kind of the idea is, and partially for demo purposes, but how do we actually build a reliable receiver without a queue? And we're going to keep the state client side. So in my case, I spun up a Redis database. Twitter API, I'm sure everyone's here used it at some time or another. Very nice libraries in every language. Everyone's used it everywhere in academia and industry. Lots of work around it. In fact, it's so popular that Spark Streaming already has it built into Spark Streaming. So you shouldn't need to build your own Twitter API. It's not reliable, but you really don't care a lot of the time, most of the time. But the rate limits really suck. And I was actually going to do so much more with Twitter for this demo, but it's just very, very tough. This stuff was very hard. Yeah, I think if you talk to Twitter, you can pay them lots of money and you'll get a better stream. All right, so I'm going to do a really quick. OK, so the code I'm going to show you right now, I'm actually running right now on my laptop, and at the end I'll kind of present it. So if you do a tweet that that mentions the data by the bay hashtag, it'll show up, hopefully. And yeah. OK, so really quick Twitter connector. Again, code vomit, ignore most of it. Very similar to the previous one, except it uses the library underneath, and it does the HTTP calls correctly, all that kind of stuff. I want to point out the one thing that allows you to kind of store the state from this API, and this is a since ID. So you can actually keep track of the Twitter ID as you're running this connector. So every time you do a call, it gives you back a list of tweets. You grab the last ID, and you kind of save it, and the next time you make a call with that since ID. And here's the reliable receiver. So again, ignore most things. Actually, the one line above this, you can see how it kind of does the caching. But notice how we're actually storing our tweets ourselves. We're storing them in an array buffer. And there's kind of two ways to get an array of this. One is the API gives you back an array. The other one is you kind of can build it up yourself. So here the API gives me back an array, and I'm just literally storing this array. And then notably, after I store the array, this is where I update my state. So the next time I want to run my receiver, I will know where I live and what I'm doing and what's going on. And note, honorable mention again, the really long sleep for 20 seconds, which is kind of brutal. Like at some point, if you have this, you're like, why do I even need this massive infrastructure? Why do I even need a computer? I can like manually do this and create a manual stream. But again, you will not usually have this long until in production. This is kind of demo purposes. OK, let's do a quick demo. Boom, 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 boom. Let's see if anyone's tweeted. Oh, none of you guys have tweeted recently.
I totally just tweeted.
Totally just tweeted? Oh, just now, right?
Yeah.
Well, so Twitter has a little like a delay, and then we have a delay, but if we give it 20 seconds, it should, the newest tweets will go green. But come on, one of you guys? Let me refresh. Oh, all right, I broke it. OK.
Did this even use a hashtag data grid? Yeah, I've never seen one.
Oh.
I think that's going to lead people astray.
Say it again? Data grid?
Alexi said to use the hashtag data grid instead of data by the bay.
Oh, well, my bad. This might be why there's fewer tweets than I'm expecting. Yeah. Well, you know what? If you come find me after, I will make the swap, and we can look at it. All right. I have a few more slides. OK. So I'm going to throw in just an honorable mention of kind of what a true reliable receiver looks like. And I mostly cover the code, but this is basically just an acknowledgement. So you do the same thing as you do with Twitter. You basically acknowledge to your queue system. And this is my previous job. We work a lot with RabbitMQ. So I end up building a little library for Spark streaming for RabbitMQ. It's my GitHub if any of you guys are suffering from the same malady. But OK, I want to briefly mention a couple more topics. So a Spark reliable receiver is meant to prevent you from losing your data during kind of the receiving process. But that's really not sufficient, because as exciting it is to not lose data in just that very first step, you could lose data elsewhere. So there's kind of two concepts surrounding this in Spark streaming, write-ahead logging and Spark streaming checkpointing. So write-ahead logging is kind of disabled by default because it's kind of slow. It needs to kind of write everything after every RDD. But if you care about it, you definitely want to enable it. And you basically, one of the nice things about these kind of distributed frameworks is the moment you're kind of being slow, and if you have lots of money, you just literally spool up more nodes. And this is both a good and a bad thing about our world, because I think we write some very inefficient code because of this, because it just doesn't matter. OK, and I hope you guys can get my joke now, because I think this is the only time I'll ever be able to make it. No? I picked the guy who technically fumbled. All right, you guys have any questions?
So in the first code example, you had a enum at the top that's something like .memory only. Can you talk a little bit about the options there and the implications?
Yes. So with Spark streaming, basically, you can the data between the processing is basically saved, and it can be saved in memory, or it can be also persisted to disk. And I believe there's I actually don't know much about it, but there's I think a couple different ways that it can be encoded, which is some of which are more concise in terms of compression, but are slower. So it tends to be kind of a sit down and think and like, well, do I have a lot of data? Well, if not, then I can put it in memory. If I have a lot of data and I'm worried about spilling over, then we can put it to disk. And if you're worried even more about it, then you can kind of compress it. So there's no really strong guideline to it. And a lot of it's kind of as you build it, you're like, well, let's optimize it a little further.
But the Spark streaming has the replay model on the micro batch.
If you do the checkpointing and the write-ahead logs, then you can bring up the data. In the case of a failure, you can actually bring up that data, but it does not arbitrarily replay a really long stream. That's not specifically part of Spark streaming, but if you're using certain types of streams like Kafka allows it, and you need to just give it a pointer, and then the whole piece will replay. But it's not part of Spark streaming, except for kind of failure situations.
You mentioned briefly write-ahead logs, and that sometimes, for reliability reasons, I guess, you need to enable this feature.
So if you don't,
More about when?
well, this is basically if you want reliability. So a lot of times, and I would actually say for most streams, you don't necessarily care about reliability. So let's say you're building a very simple Twitter listener, it's a visualization, and if you lose a few points of data, you really don't care. So the moment you start adding all these little reliability components, it adds a cost. It adds a cost in development time. You don't have to think about it, you have to do more pieces, but it also adds a resource cost. So specifically for the write-ahead logging, it now persists everything to disk. So one of the nice things about Spark versus Hadoop is that Spark runs in memory, like mostly in memory. So what this means is that on Hadoop, in order to run kind of the map reduce iteration, that usually will take on the order of minutes. And Spark, it could be on the order of seconds, which is why Spark can use this little bit of micro-batching. So the moment you start kind of writing to disk, you might be looking at a multiple of resources that you need to kind of maintain the same performance. What was the question again?
Basically, just when do you need to have this feature enabled? I guess it's essentially when you actually care about.
Yeah. So when I forgot I was supposed to be repeating questions. So when do we need this enabled? Yeah. So specifically when you really care about reliability, where you need at least once delivery or even exactly once delivery, that's where you're gonna not worry about your resource constraints and your time constraints. Mm-hmm. Mm-hmm. The back.
Do you look at the receiverless APIs that your Spark version support?
Sorry, which APIs?
The receiverless approach, like where they don't have like a separate receiver task running, but they just pull data as needed.
I have not too much. I've looked at some of the specific examples of them, but I would. The API is more complex, and I would just avoid it in the simplest cases.
Because I was just thinking that maybe it will not, it will stop us from implementing any reliability ourselves.
Sorry, I can't hear you at all.
Sorry. So I said maybe it will help us to not having us to like, implement our own reliability mechanisms if we use the receiverless approach. Because we don't have to use the writing logs, we only consume data as needed. We don't have to like receive it upfront, store it in memory or in some queue somewhere. That's what I.
So you're saying
The receiverless, that's what I was thinking. Maybe it will help us not implement any of the reliability ourselves because it's just helps us like receive data as needed, and we don't have to like store it in memory or in some other queue.
So you just build a receiver and not
So the
save it?
new API, I believe, is
Oh, you're talking about the new API for it.
new API.
Sure, I haven't looked at the new API too much yet, but thank you. It's basically saying that the new API allows a simpler approach that does not persist the data as necessary.
Like run a separate receiver task, so Spark can consume data as needed. Like one RTD maps to, like if you're using something like Kafka, it maps directly to Kafka partitions. So we don't have to like run a separate job of receiving and storing in memory. So all the other tasks can directly consume data as needed. I don't know if others have looked at it. I did some recent evaluation.
Okay, thank you. Appreciate it.
If there are no more questions, I don't want to be recorded, by the way. I just wanted to introduce myself in case there are other speakers who speak in the same room. No? I'm your friendly stage manager, track manager. I take care of the speakers. I'm also a computational linguist, so I worked on the data engineering side. I know regular expressions. So if you want to talk to me about that, please come and find me. I do information extraction and I hack systems for a living. If you have any question about this room, I can answer them too.
System hacking questions? Isn't that everybody's job?
But I hack them differently, from a different perspective. I'm a cognitive scientist by nature, so I consider all sides computers, communication, and brain. So it's slightly different. I'm also very interested in the ethics of that. Just because you can do something doesn't mean you should. Psychologists are actually very ethical in their research, if they are doing it right.
Okay, thank you guys. It's been a great audience. And I'll stick in the correct hashtag.